Hey there, all you amp nerds out there. Welcome to today's episode. We take care of a Fender Super Reverb. As usual, I'll show you how to fix the flaws, and there are a lot in this case. But first of all, let's talk about the title of this little amp movie, Stevie Ray Knew Why. Well, the Super Reverb was an important part of his rig throughout his entire career. He played Marshalls, Dumbles, even Tweed amps, but this one played an important role in his signature clean sound. And he knew why, because these amps sound fantastic. Our precious little Super Reverb obviously had rough times. Like my customer said, it is his reference when it comes to the sound. He played different amps as well, but always returns to this one. And that is the reason why it's here, to give it love and care and a good service and do everything that's necessary to bring this fantastic amp back on stage. Look at the grill cloth, shows some tear, and the speaker baffle is protruding out the cabinet. It's loose. It's not only a cosmetically problem, no, it might start to rattle at higher volumes, so I have to take care of this and fasten it and bring it back in the right position. The Tolex shows some wear too. The top side is looking pretty well. Even the hardware has not a lot of corrosion. And the look at the faceplate shows us a nice vintage look, but it's in overall good condition. The logo seems not to be the original one, because this one should have the tail. Maybe it was stolen from a later 70s Silverface amp, or it might be a new aftermarket logo. Who knows? Okay, let's take a look at the back side. Here's the rectifier tube, two 6L6 power tubes, and the fuse holder is not original. It's green. The power switch as well. It's too shiny to be original. Two of the shielding caps are missing, and the wiring for the reverb is a replacement as well. Let's fire it up and take a listen. Maybe that gives us an idea what's going on. Oh yeah, this thing is noisy. We have hum, we have wind noise. We can hear a frying pan, and we have some scratchy pots. Yeah. Yeah, this amp is very noisy, and we definitely have to do something to get that done. All kind of no-nos. Yeah, I'm sorry that the picture is not focused. Sometimes it's disgusting with my camera. Okay, the back door is removed, and we can take a look at the speakers. Either one, or maybe three of them, are replacements. You can see one in the upper left position is different. The basket is different. It's not easy to read the speaker code. I tried my best, but to be honest, I cannot identify what it is. It might be a 285 in front, so that means it's a roller selection speaker, but I'm not sure. Maybe you can help me out. If you have some information about these speakers. The tube chart has no ink stamps at all, so this chart won't help us to determine the date of manufacturing. But the serial number that is punched into the chassis, number A02818, points to 1964. And we find a date code on the choke. It's a Shoemaker 606, made in the 10th week of 1964, so I call this amp a 1964 model. The reverb transformer looks shiny and new, and it's a Hammond made in Canada transformer, so definitely not original. And I hate it when people write everything down on the chassis. I mean, you can read the schematic or look at the layout. Everything is there that you need. But, you know, to write everything on the chassis, man. And look here. Somebody drilled some additional holes in the chassis. Oh, that's looking nasty. Why did somebody do that? I don't know. Okay. Here we have the original choke, and the output transformer might be original too, but the power transformer is not. You can see it's a big one, it's a good one, probably, but it's not original. It's a replacement. So it's time to open up the doghouse and take a look what's inside. Ta-da! The moment of truth. Oh, look, somebody was in here before and did a pretty good job. He replaced the old capacitors with FNTs, so I think I'm going to leave them in because these German-made capacitors are high quality. Nice. Good job. You remember the wind, frying pan, and hum issues? Well, many times the noise issues are preamp tube related. Let me show you how just to change the first preamp tube takes care of this problem. You can hear the noise issues. And now we're going to change just the preamp tube. Noise is gone, but you know, it's an old tube and not a good one as well, so I'm going to order a complete set of preamp tubes to give the owner years of trouble-free performance. When I turned the chassis, I found a lot of crappy and sloppy jobs. Look at this. This is the socket for the rectifier tube. Everything was just snipped out because the new power transformer don't provide anything to run a rectifier tube. Look at this crap all over the place. I'm really shocked. This is the bridge rectifier that was tacked in instead of the rectifier tube. Look at this. I mean, this is high voltage, so close to the nut and the ground. The bias pot is crappy too. Look at these solder blobs. It's a plastic shaft. And, you know, somebody messed around with the bias board as well. And here's a view from the other side. This is the bias pot. It's ridiculous. The rectifier tube is damaged. See all the parts flying around inside. So yeah, this rectifier tube is good for nothing anymore. It's completely damaged. Here's another fun one. These two resistors are tied to the tube socket, and these are the balance resistors for the heater voltage. And look how it's done, you know. Well, this has to come out. All right, let's see what we find on the board. These resistors are replacements. They are new. So the orange drop capacitors are, but look at the bypass capacitors here. They wiggle around and they glue together with silicone. So no, they have to go. Somebody tagged in a Mallory capacitor to take care of the tremolo ticking, which is fine, but look at these two capacitors. They are not original, and they are, old parts, stripped out of a radio or something like this. I'm going to replace them too. This is a high voltage wire that comes from the transformer to the bridge rectifier, and look at the insulation. That's dangerous, man. Okay, let's check things out. We're going to check the capacitors first. The blue molded capacitors are very reliable. I don't expect any problems, and as you can see, they are spot on. So these capacitors will last forever. Of course, the new orange drop capacitors are alright too. The Mallory one is spot on. Okay, we have some more in the preamp section. This one is all right. .02 microfarad, spot on. 0.028, that's okay too. 0.1 microfarad, all right. 0.46, perfect. 0.1, perfect. This one shows the wrong value, but we have to lift one leg to get the proper reading. Okay, I lifted the leg and no surprise, this blue molded capacitor is in good conditions too. 0.002, that's fine. And I'm going to repeat the whole process, but now I'm checking the capacitors for leakage. So on one side we should read a higher voltage, like in this case 260, and on the other side of the capacitor it should be in the millivolt range, and as you can see everything is fine there. And again, I don't expect any problems with the blue molded caps, and of course the new orange drops will be fine too. It's just to be sure. $270. 1.9 millivolts. So here we have 244 on one side of the capacitor, and on the other side we can read the negative bias voltage 54.9 minus. Here's the same, minus 55. So all the capacitors tested fine, no problem there at all. The carbon comp resistors in these old amps tend to drift over time, so it's a good idea to check all the resistors for tolerance. It shouldn't be more than 20%, and the first one that I checked was higher than that. So yeah, it's drifted. $112 instead of 100, so this is in spec. This one spot on. So yes, at least I have to change one of the plate resistors. Here I'm cleaning the scratchy pots with some contact cleaner, and this amplifier is not just a routine. I'll show you in a few seconds what I mean. Somebody sprayed some sticky, oily stuff into the amp in the past, and this sticky stuff built up dirt and grime, and look how filthy the input jacks and the area around them is. And you can see here the wiring, it's oily, and I have to clean that up with alcohol. That will work. Alright, here we're looking at the output tube sockets, and you can see that one of the grid stoppers is already changed, but the other one is original and cooked. You know, this little fellow got very hot, and it's not too bad, but the value has drifted from 1.5K to 1.76K. So I better change that thing because it's getting very hot there. And it should be reliable. Now these two wires enter the chassis coming from the reverb transformer. They are miles too long, and it's a little bit funny how the layout looks like, and so I'm going to clean that up a little bit like this. That's much better. I removed the useless rectifier tube socket because I talked to the owner and he is pretty satisfied with the sound of this amplifier. So we're going to put in a bridge rectifier. You will see that process later on, but okay. This tube socket makes no sense. And of course I'm going to put a plate on the hole because it's a little bit dangerous to touch something. So yeah, that's something that's coming up in the future. All right, time to clean up something like the balance resistors here for the heater supply. So that's much cleaner, looking much better. And this connection to ground is really not reliable. Here I'm cleaning up the area around the power transformer. I start with cutting out everything that's unnecessary before I rebuild everything in a better way. Snip. The next step, getting out the bridge rectifier, this little dangerous thing here. Look at this. Man, that's really sloppy. I re-established the center tab and the ground connection here in the chassis, soldered them in at the same point that Fender did it in the past. Here's another grounding point that I'm going to solder in. It's the safety ground, and to get a good connection I clean up the surface of the chassis with this little pen. And it's working pretty well, as you can see. It's getting shiny, and so the solder will have good connection to the chassis. I extended the high voltage wiring and the heater wiring, so the wires will have some slack and won't be under tension. This is the next challenge, to rebuild the BIOS board and the rectifier board. But before I do this, I'm gonna pay attention to the BIOS pot, because it needs some care too. Look at this. The previous tech didn't have the right value of resistors, so he put two in parallel, and underneath the pot, what a disaster. Look at all the rust. Man, imagine that the only connection to ground is a case of the pot, only with these little lugs. And when they have nothing but rust underneath, that can be a disaster, man, for the bias. Well, here's my solution for the bias and rectifier board. It's Fender style. It was used in twin reverbs, in bandmasters. All these amplifiers had bridge rectifiers, solid state, and so it's not far away from the original. It's a good alternative, because remember, we cannot use the rectifier tube anymore because of the transformer. So here we go. It's looking pretty good so far, and you can see here that I already put in the new bias pot. I cleaned up all the rust to give it a good connection, and this is the old one. No need for it anymore. Goodbye. And that's how this area looks like after everything is connected. Yeah, I'm pretty satisfied with the result. Everything is looking clean and neat. And it's time to check if we have voltages and if the bias resistor, the bias pot works. So I pulled on my voltmeter and let's see what we see. B plus. It's jumping around a little bit. I think I have to change the battery in my meter. Okay, it settles at 482 volts. That's fine. Let's check the bias voltage, minus 56. And okay, let's see if the bias pot works. Oh yes, it does. I'm happy. Well, I think now it's time for a little overlook, and we can take a look at what has been done so far. We have 200 ohm resistors here, the artificial center tap to balance the heater voltage. We see that the wires from the transformer are extended. The new rectifier and bias board with all new parts, looking really clean, and yeah, I'm pretty happy with that. Here we have the new bias pot. I cleaned up the rust and coated it with clear lacquer to stop the corrosion. The ground connection for the resistor is at the chassis, not across the pot itself, so it's a better connection to ground than we have here. We have the center tab of the transformer connected to ground. We have new bypass capacitors. One of the drifted plate resistors is changed. Yeah, and last but not least, I changed one of the grid stoppers, the tube socket. The other one was already new, was made in the past, and it was alright. So that's it. It was a long way, but everything seems to be fine now. We should pay our attention to the bias and set the tubes to the right value. Alright, let's see. This is a little bit high, I assume, so we want to go down to 35 milliamps. Oops. Here we go. Looking good to me. I'm gonna let the tubes burn in for a little while, and then we take a look at the result. And this is how it ended up. 35, 34, a perfect match. And here are all the parts that I ripped out, cut out, soldered out. You know, it's a lot of junk ready for the bin, like the people say in England. In this case, it's not going into the bin. I put that stuff in my bag of shame that I will give to the owner so he can see what I did. So yeah, finally we're gonna check out how this amp sounds like, but I won't play any Stevie Ray Vaughan tune because I cannot. He was a genius, that's for sure, but you will get an idea how this amplifier sounds like, and in my opinion, it was one of the best Fender amps that I've ever played. So enjoy, have fun, and see you the next time.